Hello. In this example, we're continuing our discussion of section 6.3 on partial fractions. Example 6 asks us to rewrite the rational expression below in terms of its partial fraction decomposition. So notice, finding the partial fraction decomposition means determining the numerical values of the coefficients. If it were only asking for the partial fractions with the undetermined coefficients in there, it would ask you for a partial fraction decomposition form. So you need to make note of that. If it asks for a partial fraction decomposition, it means you need to go through the whole process of finding your undetermined coefficients. Now in this example, we're not actually evaluating an integral, although we could, at the end, evaluate an integral, but it's not necessary for this problem. All we're doing here is finding the partial fraction decomposition, but you will see that even just that is going to be complicated enough. So our rational function, 4x squared plus 7x minus 10 over x cubed plus x times x minus 2, first step that we need to do is factor the denominator. It's already partially factored, but we can factor an x out of that first term so that we get x times x squared plus 1 times x minus 2. Then we set up our partial fractions. We're going to have an x term, an x squared plus 1 term, and an x minus 2. Our first term is linear. Remember that x is the same thing as x minus 0, so that's linear, so we're just going to have one letter. Now x squared plus 1 is quadratic, so we're going to have a bx plus c in our numerator, and then x minus 2 is linear again, so we're just going to have d there. Next, we need to get rid of our denominator. We're going to do this by multiplying by x times x squared plus 1 times x minus 2 on both sides. So on the left, we will have just our numerator, 4x squared plus 7x minus 10. On the right, we are going to have the x term cancel, so we'll have a times x squared plus 1 times x minus 2. With the second term, we are going to have the x squared plus 1 cancel, so we will end up with bx plus c all times x minus 2. And then last, we have the x squared minus 2 cancel, so we're going to end up with d times x squared plus 1. Okay, well, from here, we could continue the process of, as we've seen before, we would distribute all of the things on the right, combine our like terms, set up our system of equations, and so on and so forth. But to save us some time, we are going to apply a little trick here. This equation is true for all x. So let's pick some x values that simplify it. For example, if we picked x equaling 0. Now the reason why I picked x equaling 0 is it zeroes out this term. So also it's really easy to substitute in. So on the left we're going to have 4 times 0 squared minus 7 times 0 minus 10. On the right we're going to have a times 0 squared plus 1 times 0 minus 2 plus that term is going to go to 0. And the last term is going to go to 0 as well. So these two are because of the x factor in those two terms. So we end up with negative 10 is going to equal negative 2a. So a is going to be 5. And there is one of our a values, or sorry, one of our undetermined coefficient values already. So now, let's think of another x value that we can substitute in that would make it really easy. We can't zero out x squared plus 1, But we can zero out x minus 2, and we can do that by picking x equaling 2. So we will have 4 times 2 squared minus 7 times 2 minus 10. This will equal, now our first term goes to 0 because of the x minus 2. Our second term also goes to 0 because of the x minus 2. And then we'll have plus d times 2 squared plus 1. And now these two terms go to 0 because of the x minus 2 factor. Okay, so a little bit of arithmetic then. We are going to get, let's see, 16 minus 14 minus 10 will equal 10d. On the left, we are going to have yes, somewhere in here, my positive turned to a negative. Sorry about that. Let me fix that before I continue. So this should be a plus, that should be a plus, that should be a plus. So it didn't affect our previous value because that went to 0, but it is going to affect this. There we go. That seems more like it. Okay, so now on the left we're going to have 20. 30 minus 10, which is 20. That's equal to 10d, so d is equal to 2. Okay, so we have 2 of our values. Unfortunately, we can't find what b and c are because there's no other x values that we can, or using this trick, because there's no other x values we can plug in to zero out the x squared plus 1 term. So, to find b and c, B and C, we will need to follow the steps for finding the undetermined coefficients. So this means I am going to go back to 4x squared plus 7x minus 10 equals a times x squared plus 1 times x minus 2 plus bx plus c times x minus 2. I'm running out of room here, sorry about that, plus, actually let me squeeze it in, plus dx times x squared plus 1. So now from here we need to distribute everything, combine our like terms, and set up our system of equations. So we are going to have a times x cubed minus 2x squared plus x minus 2. Then we'll have plus bx plus c times x squared minus 2x plus dx cubed plus dx. Bunch of algebra here. Ax cubed minus 2ax squared plus ax minus 2a plus bx cubed minus 2bx squared plus cx squared minus 2cx plus dx cubed plus dx. Now, if we combine our like terms, we have a plus b plus d x cubed. So we can see where that comes from, ax cubed, bx cubed, and dx cubed. Then we have a negative 2ax squared, a negative 2bx squared, a cx squared. So we're going to have plus negative 2a minus 2b plus c x squared. Then we'll have plus an ax minus 2cx and plus dx. So we'll have plus a minus 2c plus dx. And last, our constant terms, we have a negative 2a. That's all we have. So pulling down what we have on the left, 4x squared plus 7x minus 10. There we go. This gives us the equations. A plus b plus d. Notice, this is our coefficient of x squared. Sorry, of x cubed. We have no such term on the left, but you can think of that as 0x cubed. So this means that a plus b plus d is going to equal 0. Next, we have our x squared terms. So that's a negative 2a minus 2b plus c, and that's going to equal 4. Then we have our x terms. A minus 2c plus d equals 7. And last, our constant terms, negative 2a equals negative 10. Well, notice we could pretty easily solve the last equation to get that a is equal to 5, but we already had this. In fact, we also have that d is equal to 2. So let's substitute that in here to simplify our system a little. Substitute in a equals 5 and d equals 2. So that's going to give us b plus 7 equals 0. We will have, let's see, negative 10 minus 2b plus c equals 4. Negative 2c plus 7 equals 7. And then, of course, negative 10 equals negative 10. So notice, the first equation very clearly gives us that b is equal to negative 7. And the third equation gives us that c is equal to 0. If you subtract 7 from both sides, you get 0 there. Or you could have also used the second equation to figure out what c is. But since we were able to figure out the a and d values using our trick up above, then substituting in made it really easy to solve our system of equations. So we need to find a partial fraction decomposition. We have found the 4 values of our undetermined coefficients, but the partial fraction decomposition is these things substituted back into the partial fractions. So our final answer should be that 4x squared plus 7x minus 10 all over x cubed plus x times x minus 2 is equal to a, which was 5, over x, minus bx plus c. B is negative 7, c is 0, so we're going to have negative 7x, oops, that should be a plus, over x squared plus 1, and then plus d, which was 2 over x minus 2. And notice, if you want to write this as a negative 7x over x squared plus 1, that is okay as well. So our final answer is right here. Now, just as a side note, if we were asked to integrate 4x squared plus 7x minus 10 over x cubed plus x times x minus 2 dx, this would be equal to the integral of 5 over x dx minus the integral of 7x over x squared plus 1 dx plus the integral of 2 over x minus 2 dx. Our first term would be a 5 natural log absolute value of x, minus our second term, we would have to do a u substitution there. U would be equal to x squared plus 1, du would be 2x dx, dividing by the 1/2, or by the 2, we would get a 1/2 du equals x dx. So we end up with 7/2 integral of du over u. And then we'll have plus 2. You could think of doing a simple substitution for the denominator there, but it's simple enough that I wouldn't require you to write it out. So this ends up being 2 natural log absolute value of x minus 2. So we get 5 natural log absolute value of x. Then we have minus 7/2 natural log absolute value of u plus 2 natural log absolute value of x minus 2. Now that we've gotten rid of our integrals, we would add c, and the last step is to substitute back in for u. So we would get our final answer like this. Okay, so if you haven't figured it out yet, when integrating these rational functions, natural logs are very common. They won't always be the antiderivative that you will choose, but they will come up a lot of times.